Hello everyone. In this video I am going to demonstrate 12 volts DC to 30 volt DC power supply. This is an SMPS based power supply and it is basically a driver used to drive LED street light. As you can see here, this is how the driver looks like. The driver works with an input voltage of 12 volts DC and it generates 30 volt DC. This is ideal for solar panels. As you can see here, this is the control part. This is the control IC. And these are the two power IGBTs. These are the two power MOSFETs. And here, this is one driver transformer. Here you can see below. This is one driver transformer, and this is the main power transformer. Here you can see this is the. You can see here this is the LED light module. This is 50C4000F. So here you can see this is how the setup looks like. I am using ICTL494. I am using two MOSFETs IRF840 and I am using two IGBTs 25N120. You can see these are the two heat sinks for these two IGBTs, and here also I have provided heat sink for the MOSFETs. This is the output Schottky rectifier. Here comes the filter, and from here you can see one sample is fed to the TL494 as a feedback. I am going to show the circuit diagram. The operation will be very clear. So as you can see here, this is the circuit diagram. I am using a control transformer. This transformer is used for control circuit, and this is the power transformer for powering up the power section. Here you can see this control transformer is used to control this ICTL494, and here you can see the output of the ICTL494 is fed to this first driver transformer, and the output of this driver transformer is fed to these two IGBTs, and finally the output is taken and it is fed to this Schottky rectifier followed by this filter capacitor, and you can see here a part of the output is fed to the input of the TL494 pin number 1. You can see here, and you can see here this is the TL494 total circuit details. This is how the setup should be wired. And here you can see this is the LED module, and here you can see this is 147 ohm 2 watt resistance. This is for future use. I am going to use it for the current monitoring and overcurrent tripping. So here you can see I am using a variac. I will adjust the variac, and I am going to feed the entire circuit. So this is how the circuit looks like. This is the complete circuit diagram. I am going to attach the circuit diagram in the description link. This is how the setup looks like. So now, as you can see here, now I am going to power up this LED lamp. This is the load for this setup. So as you can see here, first of all, I am giving power to the control section. You can see the control circuit is now on, but the power circuit is not on. You can see the light is still not glowing. So now I am going to feed power to the circuit, as you can see here. So now I am going to feed power to the circuit. You can see the LED is glowing. You can see the LED is glowing. The input voltage is 22 volts DC and the output voltage is 26 volts DC. The control voltage is 2.5 volts DC. So this is the setup. This is how the setup works. Thanks a lot. Thanks for watching.